Okay, Wildcats. Today we're at Journal, page 15, solving absolute value inequalities. Conjunction, connected and. Conjunction is a compound statement formed by joining two statements with a connector and. If the statement is absolute value less than a number, the solution is x is greater than a number and x is less than a number. If the statement is absolute value less than or equal to a number, the solution is x is greater than or equal to a number and less than or equal to a number. The solution also could be no solution or empty set. Disjunction, disconnected or. A disjunction is a compound statement formed by joining two statements with the connector or. If the statement is absolute value greater than a number, the solution is x is greater than a number or x is less than a number. If the statement is absolute value greater than or equal to a number, the solution is x is greater than or equal to a number or x is less than or equal to a number. Solving absolute value inequality steps. Step 1, isolate the absolute value. Step 2, apply the absolute value definition. Step 3, solve for the variable. Step 4, sketch the solution on the number line. All right, if you would update your notes. Now your notes are updated, let's take a look at the examples. Okay. Solving the absolute value inequality below. Show answers on a number line. All right, so step 1, we isolate the absolute value. Now, before we do anything else, I want to go ahead and change example 1. So let's change that number to 2 and that number to 4, okay? Now, once you have that change, we see that the absolute value is isolated. So now we're going to apply the definition. So P plus 2 equals 4, and P plus 2 equals negative 4. Okay, now we're going to solve for P. So subtract 2 from both sides. So P equals 2. Subtract 2 from both sides. P equals negative 6. Okay, now we solve for the variable. Now we're going to sketch a graph and then sketch our solution on the number line, okay? So to sketch a graph, you want to go ahead and draw an x and y axis. And I wouldn't add some tick marks. So like here, 1, 2, 3, 4, negative 1, negative 2, negative 3, so on, and 1, 2, kind of evenly spaced. You want to do that. And the reason we do that is we want to sketch a graph. So we're going to graph the left side and then the right side, okay? All right, so here, the plus 2 means that we shift the vertex left 2 units, so 1, 2. Okay. Now we know that graphing by direction, we go right 1, up 1, right 2, up 2, right 3, up 3, right 4, up 4, right 5, up 5, right 6, up 6, right 7, up 7. Okay. And then we know we go left 1, up 1, left 2, up 2. And again, you're sketching, to be precise, but you want it to be close. So left 3, up 3, left 4, up 4, left 5, up 5. Okay. Let's kind of fix those dots, make them a little more precise. So we're just sketching, but you want it to be reasonably accurate. Okay, now that was the left side. Now let's graph the right side. So we know we have a horizontal line at 4. So 1, 2, 3, 4. So that's a horizontal line at 4. Now you can see that it intersects here and here. So we moved it down to find the x value, or in this case the p value. And you'll notice that the p-value is 2 and negative 1, 2, 3, 4, 5, 6. Okay, so 2, negative 6. Now, this says when the function is less than 4. So this, you see here, is when it's less than 4. Okay. So for the number line, here's our number line. So we know that our solution is between negative 6 and 2. Okay. So going back to our notes, we know that we use this notation. So we know that P is greater than or equal to -6 and less than or equal to
Brianna
2.
Latuada, please come to the front office. Brianna Latuada, please come to the front office. Thank you.
All right, I apologize for the interruption. That's what happens when you make a video after school. You get interrupted by announcements. All right. So now we're going to graph there's 0. We know this is 2. This is -6. So we know we have a closed circle at -6. We know we have a closed circle because there's a line underneath. And closed circle at 2. And we're shading in between -6 and 2. Because that's where the absolute value is less than 4. Okay, so go ahead and finish up example 1. All right, let's take a look at example 2. All right, now step 1, we want to isolate the absolute values. We want to add 2 to both sides. We have the absolute value of x is greater than 0. Now, when it's greater than, it's or. No, I forgot. When we know it's less than, it's and. Okay. Now we want to apply the definition. So x is equal to 0. Oh, wait, I'm sorry. Almost made a mistake. Oh. And you want to be careful. This can happen very easily because you see 0, but you forget you added 2 to both sides. So it's x is greater than 2. There. So just be careful. I'm kind of glad I made a mistake so I can point out to be careful not to make that mistake. And that you got to remember, if you added 2 to both sides, it's now 2, not that number. Okay. So now we apply definition to x equals 2 or x equals -2. So now we're going to sketch our graph. Okay. And you can kind of sketch your graph based on the solutions. You know that 2 and -2 is probably as far as you need to go. So that's why I have 1, 2, -1, -2. And that's kind of 1, 2, 3, 4. So this one's easy in that since we're graphing the parent function, we know that points are 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, -3, 3. Okay, so that's the left side. Now, we're going to graph a horizontal line at 2, so 1, 2. Here's just sketching, but you do want it to be reasonably accurate. Now you can see here that intersects here and here. You scroll down here, we can see that we're at +2, -2. Okay. Now, this is saying when the absolute value is greater than 2. So that's here and here. Okay. These are where the function is, the absolute value is greater than 2. Okay. So we know this is an or statement, so we go to our notes. So we're here, or sorry, here, right? So we know that x is less than -2, right? Because this is x is less than -2. And this is x is greater than 2. So x is less than -2 or x is greater than 2. So when you graph the number line's here. We know here's 0. We have, oh no, almost made a mistake. These are, and you always want to check, there's no line underneath, so this is an open circle here and here. Okay, so we have an open circle at -2, and we have an open circle at +2, and we know it's less than -2 and greater than 2. Or I should say, or. It's x is less than -2 or x is greater than 2. Okay, so if you would finish up example 1 and 2. All right, now let's go ahead and omit example 3 and 4, and let's look at example 5. Okay. Now our first step is isolate the absolute value. So we're going to subtract a from both sides. So we get the absolute value of x minus 4 less than negative 3. Okay, so now whenever you have a negative number on the right side of the absolute value, you want to sketch the graph before you apply the definition. So let's do that. Okay, so minus 4 means we move the vertex to the right 4. So 1, 2, 3, 4. And then we graph by direction. So we know we go right 1, up 1, right 2, up 2, right 3, up 3, left 1, up 1, left 2, up 2, left 3, up 3, left 4, up 4, and so on here, here, and here, continuing the V. Okay. Look over here. All right, and now we're going to graph the right side, which we have a horizontal line at negative 3. So negative 1, 2, 3. Now, this says less than, so we shade below. So it's less than negative 3. And you can see here, at no point is the shaded region overlapping the absolute value. So this would be no solution. And then when you graph that on the number line, you leave the number line blank. Okay, you don't shade anything on the number line. Okay, let's take a look at example 6. Okay, we're going to isolate the absolute value, so subtract 1 from both sides. The absolute value of x plus 3 greater than or equal to negative 3. Again, anytime you have a negative number on the right side of the absolute value, you want to graph before you apply the definition. Okay, so this plus 3 means we move left 3 units. So we're going to left 1, 2, 3. And we're going to graph by direction. So we graph right 1, up 1, right 2, up 2, right 3, up 3, 4, so on. You're just sketching. You want it to be reasonably accurate, but it doesn't have to be completely accurate or precisely accurate. Just be pretty close. All right. So here we have a horizontal line, negative 3, 1, 2, 3. Now, this says it's greater than or equal to negative 3, so we shade everything above negative 3. Now, you can see that every part of the function is shaded, so we would say that this is all real numbers. Now, what that looks like on the number line solution is it's the number line shaded. Every solution is a solution. Okay. All right, if you would finish up your example, start working on your assignment, and have a wonderful Wildcat day.